Oh, I'm going to get started. Let me minimize. You can see my screen, right?
Yes.
Okay.
Yes, we see it.
Okay. So I'm going to talk about CryoEM workflows on Kebnekaise. So let me first say who my target audience is. First, I was hoping to use this as a way to recruit people to who are already using CryoSpark to use Kebnekaise. And then second, I wanted to just chat with the HPC2N people to help them understand our needs. And third, if there are people from other fields that are already using HPC2N, but they have kind of common problems that we share, they might find something useful from this also. So, um, so here's an outline of what I'm going to talk about. First is why do we bother with cryo-EM? And I'll go very quickly through some kind of theory of the workflow, and then I'll talk about CryoSpark, and then last I'll talk about other cryo-EM software. So first, why cryo-EM? Um, So, I mean, with any structural biology technique, the goal is that if we understand a three-dimensional structure, that helps us understand the biological function and that this knowledge is valuable. And cryo-EM has become popular in the last few years. The Nobel Prize in Chemistry was awarded in 2017 for the kind of development of cryo-EM, and it was responsible for my first trip to Sweden, so I could attend the Nobel lectures. Yeah. So I'm not going to go very I'm not going to go into the theory much at all, but there's a lot of resources available. This website is called DM Learning. The notable content that I know of is a series of YouTube videos by Grant Jensen that's depicted on the lower left here, that goes fairly in depth into the theory of cryo-EM, and these two books by Joachim Frank that are excellent reference books. You can find just about everything in these. Okay, so very briefly, we have 2D images, and we want to make a 3D reconstruction from those images. What are the requirements? So to get three dimensionals from 2D images, we need to have images at different orientations. We need many images, which I'll get to in a moment, and we need to know what those orientations are. So I'll focus on why we need many images, and it will answer uh, a question that will come up later, or a problem that will come up later, is why our data sets are so big. So this is a raw image of ribosomes. Um, on so so these dark splotches here are ribosomes, and they're embedded in a non-crystalline ice. And maybe to an untrained observer, it may look like smudges on a sidewalk. But this is considered a famously well-behaved and high signal sample. So um, the reason that we need a big data set is that we're going to take advantage of the averaging of presumably identical molecules and try to build it up and get a good signal so that we can get a nice reconstruction out of it. So let's go into CryoSpark. So CryoSpark is the most widely used cryo-EM single particle software package at the moment. This is just a screenshot from their website. And here's a very oversimplified workflow of what you would do in CryoSpark. So the first thing that you do is that you import your movies. The raw data are a series of images. Yeah, there are a series of images stacked into what we call a movie. Then we do what's called motion correction, CTF estimation. We pick particles, we extract those particles, we classify them, or clustering in mathematical terms. Then we do an ab initio reconstruction, we refine the orientations, and then there's other steps you can do. So the most important steps are GPU based. Some steps are CPU based. I've omitted most of them, but so for example, when you've done the 2D classification, you typically will go and select the best 2D classes, and that's done manually, and that you just use a CPU power. But the most important steps are um, that are ported to the GPU. The most intense step that you'll typically run is refinement. This will, yeah, depending on the data set, it could take hours or a couple days even. Um, Yeah, so some other steps that use the GPU are motion correction, CTF estimation, and 2D classification. And so now let's go into running Kreisberg at Kebnekaise specifically. So for people that are users of the EM facility, so I'm from the Umeå Center for Electron Microscopy. I didn't say that. The acronym is USEM. So for USEM users, our wiki has internal information about it. Um, and for people that aren't members of USEM, the steps to get an account on Kebnekaise. This isn't new if you're already using Kebnekaise, but if there are people that haven't used it, these are the steps involved. First, you get an account at NICE, and then you apply for a local compute project, and then you apply for a local storage project. Once you have those credentials, you log into Kebnekaise via SSH or graphically using ThinLink, which is a free download. I'd like to focus on the storage project because for me, this is what makes Kebnekaise such a nice compute facility. Um, so because our data sets are so big, and the second bullet here shows the typical size of a data set. So our microscopes can generate on the order of 5 TB of data per day. So a typical data set the raw data ranges from 1 TB to 10 TB. I mean, there's a range. You can be below or above it, but probably 90+% of projects will fall in this range. And then once you have the raw data, then you're going to create some intermediate files, so it isn't unusual for a single project to use 20 TB of disk space. So Kebnekaise is one of the clusters that can accommodate such large data sets. Yeah. So once you have these credentials, so some these instructions that I'm going to go through are adapted from the HPC2N documentation, and then I added some of my own observations. So CryoSpark is free for academic use, but you need a license. To get the license, you go to their website and you fill out a form. They'll send you a license key typically within a day, and then with the license key that they send you, you go to your home directory on Kebnekaise and you create a file called CryoSpark license. And then in the first line, you enter the code. Uh, in my case, it was 33 characters, and then your email address. Um, to load CryoSpark, you need to load these modules. Um, and yeah, short answer, you need to load these 3 modules. I do this often enough that I just created an alias and I list the modules afterwards so that I can see that it actually worked. I'll show a quick demo later on. Let me just go find a step that it would be helpful to illustrate it. Actually, let's do it now. So I've logged in. Um, and I will type use CryoSpark. Is my font size big enough? I can't remember if let me know if you can't see. I don't know how to enlarge the fonts here. So hopefully this is big enough. So I have loaded the modules. So CryoSpark is loaded. So it should be fine. So let me go back to the slideshow now. So once you start CryoSpark, well, so I've already started CryoSpark, so I don't need to do this. Um, so when you start CryoSpark, it will give you a URL that you can enter in the web browser, and then you can control CryoSpark from there. I've already done this, so I don't need to copy and paste it. Let me find my browser. So this is what the front page of CryoSpark looks like. So if I click on this little file cabinet icon, it shows my list of projects, and I can click on one of them. It creates what's called a workspace, which has your actual jobs. And then this is a list of all the jobs that I've run. Yes. So let's go back here. Okay. Um, right. So when you start CrossPark for the first time, there's some things that you need to do. Um, So this port number in the previous page. So in this case, it was 39049. There's a file called master config that you need to make sure that it agrees. I don't remember if it's done automatically because I only did it, I guess, twice. So make sure that those port numbers agree. And the other thing you should do is create an account, and you do that with this command line command, crossbar reset password, your email, and then your password. Something that is easy to forget, especially if you've run CryoSpark in like a local installation, is that to run CryoSpark, you have to be in the directory where you first created your Cryos. So the place where you created CryoSpark or you ran it for the first time, you have to go back to that directory, or else it will start a new CryoSpark instance. So in my case, let's go back to the terminal. So yeah, this is my directory, and this is a Swedish keyboard. So when I started CryoSpark, it created a bunch of lane directories, which I'll describe in a moment. And these config files, this is the one where you should check that the port number agrees. Actually, let's look at this. Yeah, so this is the place where you should make sure that the port number agrees with what was on the screen when you started CryoSpark for the first time. Yeah, so I need to be in this directory when I do any CryoSpark commands. So keep that in mind. Let's resume. Okay, so I pointed out these lane directories in the CryoSpark directory. So each lane in CryoSpark corresponds to combinations of resources. So typically a number of GPUs, CPUs, memory, etc. If you're familiar with Slurm, each of the lanes corresponds to a separate Slurm job script. So there's a lot of tricks that were unique to Kebnekaise that I learned as I was getting it running. So when you run CryoSpark for the first time, the CryoSpark wrapper that we run on Kebnekaise will create various directories which each correspond to one lane. So I'll go back to the terminal in a moment. So for each of the lanes that you want to use, you have to connect them, and I'll show what that means in a moment. Um, so and what that means is you're required, or it's helpful to change two files. The first one is a cluster script. Uh, let's go to one now. Let's do one that I haven't touched yet, so we can show what it looks like when you haven't. Let's try this one. Oops, I wanted to copy that. Make sure I haven't edited it already. No, that was too long ago, so I want, in case people aren't comfortable with text editors, I'll use Nano. I usually use Vim. I want to edit this one. Um, so here, oh, I should have written down what the correct project ID was. Hold on, let me exit. Do I have it shown here yet? No, I'll find one. So this is one I created recently. So this is my project code. And the runtime, I'll talk about runtime in a moment, but the default is 20 minutes, which is generally not enough. I'll change it to an hour, save it. And the second file I need to change is cluster info. This is more cosmetic, so it's not so important. Um, so this is this A100:1 is how it will appear in the web GUI. So I think I already have one that has a similar name, so I'll just add a new here so I know that it's a new one. Save it. Let me make sure I actually saved the other one. Yes, I did. Okay, so let's go back to the slideshow. There. Um, Yep. So once I'm satisfied with the changes to actually connect the lane to CryoSpark. So right now, if I do anything CryoSpark, it won't know that I created I've wanted to add a new lane. So I have to run this command CryoSpark cluster connect. So I just copy this. Nope, can I copy? Go back to the terminal, paste it. Oh, yes. So at the bottom, it will say that it successfully added a new lane. So let's actually run a short job just to show that this lane exists and what it looks like to start a job if you've never used CryoSpark before. So I've been doing software development for a long time. So I'm a little jealous how nice. So I used to not like GUIs. I was a command line person, but the GUI here is so nice that that it's good. So let's see. I'll pick one. Let's see, I think I'll use 2D classification. Yes, that's a good one. So yeah, so briefly, this is a list of all the things that you can do in CryoSpark. So if I want to look for classification, so the math people, what we call classification in EM is the computer people and math people call clustering. I think it's too ingrained into EM that we'll switch to the correct term. Um, so we need to provide some inputs. So this pane on the right here is the builder pane. So we need to populate these inputs. So we're going to give it some extracted particles. Let's see here. And to get the extracted particles, we can go to the outputs of one of the steps that we ran previously and just drag it here. And it's green, meaning that it's legal. If it wasn't legal, it would turn red when I try to drag it over. These are parameters that you can tweak if you want to. In this case, I know that the defaults are reasonable, so I can just queue it up now. And so now it's at this step that it shows the various lanes that I've connected. So this is the new one, the one that I just created, and it's available now. So until I did the connect command, this wouldn't have been visible. Um, and so before I actually start it, choosing the queue is kind of important. So let's talk about what goes into which one to use. So let's resume. Yeah, so when you submit a job, you may want to choose a lane. So at the moment, to my knowledge, CryoSpark only runs on NVIDIA GPUs. I think this will change. Yeah, I think this will change, but for now, it's best to run it on NVIDIA GPUs. What I do is I look for which GPU nodes are available. I use the sinfo command to do this. And I mean, rather than copy and paste every time I want to do this, I've made an alias called sinfo idle GPU. And that's what I'll show you here. Um, that. And so we have an H100 and oh, A6000. I don't know if I have that option. Let's see. Oh, I do not. So let's create another lane. Um, Oh, there isn't one. So let's do the H1000. Uh, it's an 80 gigabyte GPU card, so I kind of don't want to waste it. I'll just put it in the queue and it may take a few minutes to start up. Let's use the L40S. And yeah, so this is a queue that I set up before. It's for 1 hour maximum runtime. And it's going to be queued. So if I go back to the list of jobs, it will, oh, so this, I have a troubleshooting slide, and this is one that happens from time to time for reasons I don't understand. So let's just kind of fast forward to my troubleshooting slide. Yeah, here. So yeah, at the last bullet here is sometimes you get um, an error that there's multiple CryoSpark instances running, and my solution is simply to restart CryoSpark. It's not slow. It's fast, so it's not a big deal. It'll take a few seconds. And while it's restarting, the GUI will disappear. Oh, if by the way, if anyone has any questions or comments, just shout them out because I'm not looking at the chat, the chat, for example. Okay. Okay, so now it looks like everything has started. And so now this is back, and now it's launched. It's not complaining um, about multiple instances. So if I go into the job kind of page, so this first tab is the event log. This will show text and image outputs. And we can talk about the other tabs later if anyone's curious. So this is pending. The PD here is pending. So it'll take some time to start. So we can go back to the slides. Okay, so where did I? Yeah, so this is how I pick a queue. So once your job has started or is pending, there's a few ways to monitor it. One is the CryoSpark web page itself. The other is this graphical resource monitor. Um, is, I don't know if it makes sense to check it before it started, so we'll wait until it starts. But yeah, I'll show it when the job has started. And another way is to use the slurm command scontrol. If you do scontrol show job and then the job ID, that will give you some information about the job. And the job ID was also shown in the CryoSpark GUI here. Oh, it started. So go back to the beginning. So it only needed so it checks every few seconds. I don't remember the exact number of seconds between tries to submit the job. This is the job ID that those commands will ask for. So we have these noisy images. We didn't look at micrographs, but yeah, they were noisy, and it's clustering them into kind of homogeneous subsets. So these will look, and this is an iterative process, so it will look cleaner and cleaner over time. So I can tell you a little kind of short story about. So one of my previous positions in Dortmund, we had a very nice CPU-based 2D classification slash clustering program called Isaac. Um, One of my colleagues, he ported it to a GPU to try to make it faster because we had a big CPU cluster, but not a lot of people have CPU clusters. So he ported it to a GPU. It took him 3 years to make it run nicely, and then CrashSpark came out and just kind of blew everything away. It's so fast that so Isaac had some nice features, but with CrashSpark's 2D classification, you could probably run 5 or 6 classifications in the same time that Isaac took. So yeah, so better to just use the super efficient program rather than the one that maybe has some nice features. So yeah, these class averages will get better and better over each iteration. And now I can show you the monitoring um, program. So job usage and then the job number. I hope I copied it to the screen. Job usage. Nope, I didn't. I can just do an SQ though. So here's my job that's running and job usage. and it'll give you a URL that you can copy. Go back to the browser. So what we have CPU utilization, memory, GPU usage. So yeah, this is quite nice. So if this didn't exist, so I have a set of bash scripts that just runs NVIDIA SMI, the command that checks the GPU usage and writes it to a text file. This is much nicer. So yeah, this is quite nice. And the other is scontrol. This is a Slurm command. Show job. Oops. And this will show various stuff. This is usually not interesting or it's overwhelming unless something weird or unless something weird happens or if it crashes, then it's maybe helpful to look back and see why things crashed. Okay, so those are the ways to monitor the jobs, the interface, the job usage, resource monitor, and desk control. Okay, so yeah, we've already had one slight glitch when we got the multiple CryoSpark instances. So it isn't just on Kebnekaise. I've been getting this on our standalone workstations also, and it's just a matter of restarting CryoSpark. It's annoying. I don't know if it's a bug or yeah, what the cause is. Yeah, so if a job dies, CrashSpark will report an error. It looks like it's a Python. There's a traceback message. Um, Sometimes it's enough information to figure out why it went wrong, and sometimes not. There's a common generic error, is that the job is unresponsive, no heartbeat received. What the heartbeat is that CrossSpark writes to a tiny text file every, I don't know, like 5 seconds, 1 second, I don't remember. And then there's another process that monitors this tiny text file. And if there's no change, then it will report an error if it's beyond 180 seconds by default. So there's a lot of reasons that you can get this error. One is that if you have insufficient system memory, insufficient GPU memory, and sometimes for local installations, sometimes, yeah, we have kind of old workstations here. Sometimes it's just kind of struggling to keep up with the amount of data being processed. So sometimes it just isn't writing to this tiny file for a few minutes. If we gave it enough time, maybe it would have come back. So something you can do is there's a file called config.sh that gives it this threshold change. You can change it from 180 seconds to something bigger, and this has fixed some problems from time to time. But on Kebnekaise, I've run into this problem for the first two reasons. One was insufficient. No, I haven't run into insufficient GPU memory. On local machines, I've run into insufficient GPU memory. I've run into insufficient RAM, and I'll talk about that in a bit also. Yeah, and so these resource monitors, if you get one of these errors, then it's a good idea to check the resource monitors to see if you can figure out what went wrong. So, for example, if you see that in my lanes I specified 64 gigabytes of RAM. I think I've used that number in all of mine just for a safe number. Uh, if I don't specify it, I ran into a case where only like 10 or 11 was specified, and then CrashSpark used too much, and then it died. It gave me this heartbeat error. In our local machines, we ran out of GPU memory. I think. I'm not 100% sure because I ran it on a machine with a bigger GPU and it ran. So I'm assuming I didn't have a system monitor running at that time. So, but since it ran on the bigger GPU, I think that was the problem. So it's a kind of a generic error. And yeah, you have to go and check why it crashed. Okay, so um, what the kind of usability things that I needed to worry about when I was using Kebnekaise for CryoSpark. The default run times were only 20 minutes. And so for this tiny data set that I'm running right now, 20 minutes was enough for everything. But for a real size data set, it could be 10 or 100 times bigger than that. It wasn't enough. So I had a medium-sized data set, which was probably 100 times bigger. The run times were up to 3 hours. Um, in my old job, I think we had different queues that were up to 2 hours, 2 to 48 hours, and then 48 to 60 hours. Um, I think we'll need that eventually. For me, I was just running, I had one lane for each GPU type, A100, V100, L40S, etc. So talking to Pedro, we both kind of independently were thinking that maybe we can just have a generic GPU lane. It'll just use whichever GPU node is available. And I think that will save a lot of complexity because I think we can't get around that we need different lanes for different runtimes.
Sorry, we have some pretty hard into.
Oh, someone has a question? Oh, okay, I'll continue. Um, yeah, so I think we can avoid having different lanes for different runtimes. So if we can have just one GPU, like a generic GPU lane with different runtimes, that reduces the number of variables, so it won't be so complicated to pick a lane to run things. And my kind of ideal situation is that suppose we have a robust set of lanes that works for 90+% of use cases, then it would be nice if the lanes can be automatically generated and connected when you start CryoSpark for the first time so that you don't have to go through and edit the files and then you run this connect command. Okay, so that's what let's go back to my job. Might have finished by now. Yes, it says completed. And yeah, I mean, if you haven't seen the raw images, maybe it's not so impressive that these are kind of very, very detailed. Yeah, these are very detailed images. This is one of the famously well-behaved examples. So from only 20 micrographs to what 20 images, you can get a near atomic resolution structure. A typical data set requires thousands, and we used 20. So this is, yeah, a famously well-behaved sample. The system monitor is here. It shows what our memory usage was and our GPU usage, etc. Okay, so I'll talk very briefly. Oh, nice. This is roughly the timing I was aiming for. So the second most popular single particle software package is called Relion. I haven't used it on Kebnekaise, but I have used it on other clusters. And I have Swarm scripts that we can adapt if we need to. And tomography is kind of a different I haven't defined single particle versus tomography reconstruction methods. You can ask about it if you want. But tomography is a very broad technique that's used with cryo-EM and non-cryo-EM images. The software landscape, I referred to it as the Wild West. There's a ton of programs. Each of them does sometimes a very specific thing, and then there's a few all-purpose packages. And typically people mix and match, and it's a little chaotic. So CryoSpark is kind of it handles maybe 90% of single particle projects. With tomography, it's way more diverse than that. People mix and match their favorite methods. So it'll be difficult to accommodate everything, but I think the interest will grow. And a lot of the new methods are using deep learning methods, so we need the GPU capabilities. That's hard to run on local, kind of small consumer level cards. And that's all I wanted to say. Yeah, I think uh, the one other cool thing in CryoSpark is that when I look at, so this is just a kind of a linear list of all the jobs that I've run. I can also show it in a flowchart form, and it shows which jobs are connected to which other jobs. So it's like a built-in mind map. So it's a nice way of viewing what you've done. And suppose you had a dead end that you can throw away the intermediate files because they start to add up in terms of size. So yeah, there's a lot of cool tricks you can do in CryoSpark. And if you want to see what the actual result looks like, oops, wrong, I went too far. Uh, let's see, the refinement. No, this is the final. one. We don't need to see the event log. It's going to look, maybe not. So I'll just end there then. So if anyone has any questions, I will maybe stop sharing.
And I will turn off the recording so people can ask freely.
Stop. I see.